Current environmental monitoring relies on a reductionist philosophy. We track isolated variables, a temperature anomaly here, a parts per million reading there, without a working model for the underlying organism that produces them. The Gaia hypothesis defines the Earth as a rigorous, autopoietic biological entity, a self-creating system, where the biosphere and the physical environment are tightly coupled. Analyzing it requires a holistic, physiological approach. Navigating current ecological crises requires engineering a computational central nervous system for the Earth. The blueprint for this is Program 1. It consists of 4 integrated architectural layers: an ontological body map, sensor ingestion protocols, a vital signs compute model, and distributed hyperlocal dashboards. Systems engineers must build a computational nervous system from the ground up. This infrastructure represents the first layer of the Gaian Stack. It is a precise architectural mandate for data scientists, sensor designers, and modeling experts. By architecting a federated data commons, formalizing an anatomical model of the Earth, and deploying an analytical sense engine, we can translate raw metrics into readable planetary vital signs. Generating these multidimensional signs requires a shared computational core. We call this the Gaian Sense Engine. The Sense Engine continuously ingests the raw, federated data streams, runs them through the anatomical ontology, and updates the planetary body model in real time. Once the structural map is established, we must define how a planetary system technically feels incoming multimodal data. To interpret these signals over time, the engine relies on neural ordinary differential equations. These equations allow the system to infer the continuous, fluid state of the environment between discrete sensor pings. Standard environmental software triggers simple threshold alerts, warning you that a local temperature is high. The Gaian Sense Engine performs homeostatic synthesis. Homeostatic synthesis contextually evaluates an anomaly against baseline planetary rhythms. It evaluates a spike in heat and outputs a true physiological state description for that specific region. The Gaian Sense Engine mathematically translates chaotic environmental noise into a unified perception of planetary stability. The analytical output of this engine is the vital signs model. It replaces static endpoints, like raw carbon concentration, with clinical physiological indicators of planetary health. The system tracks core vital signs: pulse, temperature, respiration, blood chemistry, inflammation, and cognition. Pulse, in a planetary context, calculates the rhythmic oscillations of natural cycles, such as seasonal carbon breathing and tidal energy exchanges. By mathematically treating ecological features as coupled organs, the system integrates a coastal wetland as a functional node within the planetary renal system. Because these organs are coupled, we can trace the exact data cascade of a localized failure. The degradation of a single wetland directly alters the computed blood chemistry of the adjacent hydrosphere. This ontology forces our data models to interpret human infrastructure, shipping routes, cities, and communications networks as nested metabolic layers fundamentally constrained by the biosphere. We visualize a healthy ecosystem as a deep attractor basin that keeps data stable. Just before a tipping point, a localized ecosystem exhibits increased volatility. The amplitude of the data point increases, that is, variance inflation, and its recovery time slows down. Eventually, the system shifts into a new, degraded attractor basin. The system also tracks cognition. This acts as a measure of synaptic latency, calculating the exact time delay between a detected environmental stressor and the deployment of a human or robotic intervention. The vital signs model allows us to diagnose and treat systemic vulnerability during the prodromal phase, rather than reacting to ecological death post-mortem. Planetary intelligence requires distributed sensory motor nodes to execute actions across the global system. These nodes take the form of local Gaian dashboards and the broader Gaian atlas. They act as the localized interfaces bridging the technosphere and the biosphere. A local dashboard functions as a civic nerve ending. It translates macro-level vital signs into targeted restorative priorities for a specific watershed or biome. Once a priority is established, the execution layer takes over. This initiates a closed cybernetic loop. As the local physical intervention takes effect, the ecosystem shifts. That shift generates new sensory data, which is transmitted back into the latent space of the Sense Engine. Without the Sense Engine interpreting raw telemetry into these structured vital signs, Local communities are mathematically blind to how their specific actions affect the whole. The Sense Engine produces two primary user interfaces. The first is the Gaian Atlas, a multi-scale macro-anatomical map of planetary health. The atlas is built for deep drill downs. It allows users to transition from global weather patterns to specific bioregions while preserving the visual and mathematical interdependence of the systems, avoiding geographic fragmentation. The second output targets the local level, local Gaian dashboards. These dashboards are civic instruments. They display a specific watershed's vital signs, highlight immediate restoration priorities, and directly link a community's physical labor to the maintenance of wider planetary homeostasis. This software stack is designed to plug directly into physical reality. The data alerts generated here dictate the deployment of ecological robotics, direct the efforts of restoration eco-villages, and guide informatic biology clinics on the ground. Building the data commons, body model, and sense engine constructs a living cybernetic loop between information and action. By designing and governing this stack, systems engineers provide the infrastructure for a coordinated planetary intelligence. This moves the profession from external observation toward the active engineering of planetary self-regulation.